in particular, we basically can't put the 2 with the 3 because the 3 has an exponent. We can't divide the 2 over because the 4 has an exponent. So when it happens to be like this, and you'll get a question like this on your test, and you're like, I wonder if she will. She will. She's me. I just told you. So you're going to get a question like this. You're going to have to log base 10 both sides. Okay? So log base 10, 2, and then I put a dot here. 3 to the x plus 1 to remind myself that they're being multiplied. Log base 10 of 4 to the x minus 2. Now, most often when they didn't have the number in front, we could just take the exponent, we could drop it in front, and we could distribute. But when there's that number in front, I told you step 2 is what's either going to make you do well or be wrong the whole way through, right? So at step 2, when you have this multiplication, what you're going to do first actually is separate them by addition, and then you'll be able to do the exponent drop. So we go log base 10 of 2 plus log base 10 of 3 to the x plus 1 equals log base 10 of 4 to the x minus 2. And now we can do the exponent drop in front using power rule. The log base 10 of 2 is just going to go along for the ride, right? It always just stays along for the ride at the beginning. So we're going to get log base 10 of 2 plus x plus 1 log base 10 of 3 equals x minus 2 log base 10 of 4. So we get log base 10 of 2, just comes along for the ride, distribute this in, so I put in brackets, plus x log base 10 of 3 plus 1 log base 10 of 3 equals x log base 10 of 4 minus 2 log base 10 of 4. And then we get the x's to one side, everything else to the other. So the fastest way to actually do this would be to move this x over there and that number over here, but it doesn't really matter. You'll still get the same answer. I'll move the x's over here because that's what I've been doing up till now. So x base 10 of 3 minus x log base 10 of 4 equals negative 2 log base 10 of 4 minus x, that's not true, minus log base 10 of 2 minus log base 10 of 3. Then I have all the logs on the left and everything with an x on the, logs on the right, sorry, everything with an x on the left. Take out a GCF of x, and I'm left with log base 10 of 3 minus log base 10 of 4 equals negative 2 log base 10 of 4 minus log base 10 of 2 minus log base 10 of 3. And then I divide the log base 10 of 3 log base 10 of 4 over. And what do you get for x? What did you guys get? What did everyone get? Type it in your calculators if you don't have an answer. Well, now we have two answers that are not the same. We need to get to a third to decipher through. I think it's 15.8. You got 15.8? Now, guys, we shouldn't be humming and hawing as to whether we're right or not. Why? You can literally type this lovely thing into y1, in brackets, y2. And then what do I look for? Where they intersect, which should be 15.8. So if this was a multiple choice or numeric response where I didn't make you actually show your work, you could literally just type it into your calculator. Hence why it's probably a written response, if I were a guessing human.
I think I forgot a negative log 3. What did you get?
You got 8 point something.
I didn't get either of those, but I think.
Did you type in negative 2 log 10 or did you type subtraction?
I did the negative.
Yeah. Okay. So, just so you know, I taught you a tiny bit of trig, And then I intend on not teaching you any more trig till after the break. The reason why I taught you a tiny bit of trig is because I taught you the stuff that people struggle on first so that I can ask you every single day a little bit of questions of it. Make you convert between radians to degrees, make you convert between degrees to radians, that's calculus. And then make you convert that way, make you draw them, make you give me rectangles, coterminal angles, make you fill out the unit circle, right? So you have all that stuff super solid. So then we start trig after the break, we're really good at it. Okay? So I'm still going to make you guys do those reviews. Review of that material on Wednesday and Thursday at the beginning of each of those classes. I'm going to review trig. Okay? What I intend on doing is actually finishing the other functions unit. So we're going to do it, the addition and subtraction of other functions today. I just handed you the notes. Then on Wednesday we're going to do multiplication division. And then on Thursday we're going to do, it's called function notation. It's called composition of functions. It's 3 lessons long. To be honest, when we come back after Easter break, all we have left is trig and perms and coms. That's our last 2 units. So trig just happens to be chapter 4, 5, and 6, and it lasts forever. And then perms and coms and binomial theorem. Okay? That's all we have left in 30-1 after we come back to Easter. Perms and coms and binomial depends on the person. Some people find it easy, some don't. It's weird. It's like weird. It's like you have the word apple. How many ways can you rearrange apple where the P and the A are together? Yeah. So it just depends on if people get it or not. Okay. So can you turn to your notes, please? That's not where I want to be. So you're here. So we have functions and prior skills, so we're going to use our prior knowledge. Basically, a lot of it is from grade 10. Just creeping back at you to do these. So we're going to evaluate the following expressions given the functions below and write the corresponding ordered pair. So when you were in grade 10, your teacher would say, don't worry about f of x, it's just y. Don't worry about g of x, it's just y. Don't worry about h of x, it's just y. You can just put a y. It's often what it is. Now, the reason why you label them something different is because G, H, F, and J are all different functions. So if I sketch them on a graph, I could label them as G of x, F of x, H of x, J of x, and not have to write the equation out, right? And I would know which one goes with which. So that's why you label them different letters. But here, remember in grade 10, you were taught that when the number's in the brackets, what does it go in for, x or y? This is a J of what? J of x. J of x. We agree? So what's it going in for? X, because it's in the spot where x is, correct? So J of 2/3 just means for every x in J of x, I'm putting in 2/3. So I'm going to go 2 times 2/3 plus 7. This is just function notation. You multiply fractions, you need a denominator because you multiply numerator times numerator, denominator times denominator. So I get 4/3 plus 7. If I wanted to, I have to make a common denominator. You can type it in your calculator. Common denominator would be of 3. So I would get 4 plus 21 all over 3, which is 25/3. And all I found really is a coordinate. So when you plug in an x value and you get out a y value, you have found a coordinate. So down here I have a coordinate that's at 2/3 and 25/3. So you're either inputting for y and solving for x, or you're inputting for x and solving for y and you're getting a coordinate. You guys did this in like inputs and outputs in junior high. Even if grade 10 was a little bit shoddy, because you kind of didn't have school for a lot of it. After much. Okay, here we have g of x equals -13. What does that mean? That's a y value. That means I take g of x, I put it in my hand, and I throw it away, and instead of g of x, I'm going to have it -13. It's just replacement notation, right? This is saying g of x equals -13. So if I wrote out the g of x equation, g of x equals -5x minus 3, well, g of x actually equals -13, so I'm going to put a -13 in here. -13 equals, and the rest stays the same, -5x minus 3. So this is actually my y. So it's going to go here. And then I need to isolate x. There are notes in front of your face. You should be filling them in with a pencil. I didn't print them to just look pretty on your desk. Okay. Just ratted out who was the person who was not filling it in by talking. So, negative 10 equals negative 5x. And then I want to get x by itself. So I'm going to divide by negative 5. And x equals 2. So I found a coordinate. Whenever I plug in an x and get a y, or plug in a y and get an x, I'm literally getting one coordinate on that graph. We did this in polynomials, right? We've already done this in polynomials. H of negative 16. Try out f for me. So you should be getting negative 1. And you could write this as h of negative 16 equals negative 1. That's function notation for representing a coordinate. Correct? We talked about this in polynomials. Also, after the break, you're going to have a cumulative exam as well. And then cumulative. Cumulative. Yeah, on the day you get back, I'm Satan. Pleased to meet you.
I will tell your other daughter that's
I would never give it to you on the way. That would be terrible. I am not that mean. No, after you come back. Like, I'm just saying, after the break, there will be a cumulative, which will not be on the first day you come back. And not even the first week you come back. It'll be the week after.
second day.
Will not be the second day. That's mean. Okay. It will not be in the first week when we come back. It'll be the week after. Okay. I'm scared that you actually thought that was a possibility.
Well,
You think I'm really mean.
You said we'll have one when we get back, so I just
You just thought I was so mean.
all in one day.
Okay. We have g of x equals 41. So we can fill 41 in. We get 41 equals negative 5x minus 3. So they gave me the y. And so I'm going to get 41 plus 3 equals negative 5x. 44 equals negative 5x. Divide by negative 5. X equals 44 over negative 5. Or I can write it as negative 44 over 5 because the 5 can move. Okay, we'll look at I and then we're going to move on. So I has h of x equals negative 2. The reason why I want to do that one is because it's irrational. So you get negative 2 equals 8 over 8 minus x. What am I going to have to do? How do I get x by itself? Take the entire denominator and multiply it up and multiply it up. So we're going to get negative 2 bracket 8 minus x equals 8. And the reason why we get that is we're multiplying by 8 minus x. Now, do I actually need to distribute the negative 2 in here? No, I could actually just go right ahead and divide it over. You could distribute it in, you'll still get the same answer. Most of you will distribute because you see brackets and it's like an addiction to distribute. We made you that way. So it's 8 minus x equals negative 4 minus 8. Negative x equals negative 12. Divide by negative 1. X equals 12. Okay? I'm not going to make you plot coordinates. We've done it all year long. This is when we used to, this example's from when we used to start with this as our first unit, but you can plot a coordinate at this point. If not, please tell me you can. Okay. So as a coordinate, what would this one be? We're not plotting it, but what would it be? Negative 1 and 1. And we did this in polynomials. This would be 2 and 7. 1 and negative 1. So these are just function notation for coordinates. It's the same thing, right? We've talked about functions before. How do you know if something is a function? It passes the what test? Nope. Vertical line test. So if something is a function, every x can only have one y. So when you draw a vertical line, it only crosses through once. Now, how do you check an inverse is a function off of the original horizontal line test? That's where you were at. Okay, next page. So this is just function notation. We're just reminding you of how to do these. So if I ask you, here's two graphs on here. This is why we label them different, f of x, g of x. So here we have, find f of negative 4. So I go to negative 4. And if I needed g of negative 4, what would my answer be? Yeah, it does not exist, right? But f of negative 4 is actually this absolute value graph, and it is at negative 2. G of 0. So I go to 0, and I follow it up to the g graph. What is it? 3. G of 3. Yeah, it's at 0. F of 3 is at 5. What happens when I give you g of x equals 0? What am I giving you? I'm giving you y. So when I look when y equals 0, what are my x's on g? 3 and negative 3. What about f of x equals 0? F of x equals 0 is when y equals 0. So it's basically the x-intercepts of f and g, right? So it's going to be negative 2. So those are all just little summaries of things you're going to need for this. We're going to do sum and difference. Sum and difference is addition and subtraction. So here we have, for each pair of functions, determine h of x if f of x, h of x equals f of x plus g of x. Okay? So we have f of x, we have g of x. They tell us that h of x equals f of x plus g of x. Now sometimes they'll write it like this. H of x equals f plus g of x. If you ever see it in that format, which they sometimes do, all that means is h of x equals f of x plus g of x. And this format's better, because I literally just put the two functions in and add them, right? So if you see f plus g in brackets of x, just rewrite it as f of x plus g of x. It means the same thing. Now, our h of x then is going to be f of x, which is root x minus 4, and g of x, which is 12. That's actually a radical function, isn't it? What's the rule about radicals? How do I figure out their domain? What can't be under a square root sign? Negative. So remember how I found the domain? I just took what was underneath the square root sign and I did what with it? So what's under the square root is x minus 4. What you tell me can't be negative? What's a way of saying can't be negative? It has to equal 0 or greater. So remember we went x minus 4 has to be greater than or equal to 0. Add my 4 over. X has to be greater than or equal to 4. I also chose to do this unit in this spot because it also starts reviewing your other units. Okay, the other thing. I'm going to sketch both these graphs on here. We're going to have a little discussion. So how do I sketch graphs? Yeah, put square root x minus 4 into your calculator. Where does my radical graph normally start? 0, 0, and I go up and to the right. Now it's going to be at, nope, 4, 0, and still be up and to the right because there's no reflections. correct? I'm going to make my x scale be 2.
Are you just wanting square root of x minus 4?
Yeah, and my y scale being 2. So square root x minus 4 starts at 4, 0. I'm making my x scale 2, so it's going to be 4, 0.
Numbers.
Yep. Should be 5 and 1.
1.
5, 1. Remember, I'm making them both be 2, so I need to make both of them be 2. I just didn't do it. Oh, gosh. 5 and 1, so that's here. Then what?
6 and 1.4.
6 and 1.4.
7 and 1.7.
7 and 1.7.
8 and 2.
8 and 2.
9 and 2.2. 10 and 2.4. 11 and 2.6. 12 and 2.8.
So it's going to look something like that. The other one is y equals 12. So I go to where y equals 12 and I draw a what? Horizontal or vertical? 2, 4, 6, 8, 10, 12. So I had to make my y scale be 2. Boom. Now, when adding and subtracting functions, the domain exists where both graphs exist. You can't add a function where the other one doesn't exist. You can't like add f to g if f doesn't exist at -2. What do you're adding 12 and I have no idea. If you're going, hey, I want to add 12 and there's nothing there, then you can't add them. You can't be like, I'll pretend it's a 7. Like you if there is no y for it, it doesn't exist. So when you're adding and subtracting functions, the domain can only be where both of them exist. So where do both these graphs start at? Start existing at? X equals 4. Do you see this? 4 or greater, right? Oh, look. X is greater than or equal to 4. So the graph can only exist where both of them exist. So do I actually have to find the combined function if they ask me for the domain of the combined function? No. I just need to find the domain of both of them. So the domain of this one is x is greater than or equal to 0. The domain of this one is xer. And I can only pick the domain of where they both exist. So the domain of h of x is going to be x such that x has to be greater than or equal to 4, xer. Now you have to actually graph it to get the range. So type the h of x into your calculator. You can get your domain from where they both exist, but the range you actually have to put the equation into your calculator. So type the h of x into your calculator. Square root x minus 4, and then plus 12. After your basic window, why aren't you seeing it? Because the graph is normally at 0, 0, but it's actually been moved 4 to the right and 12 up, and it's still up and to the right, correct? So what's my range going to be? Greater than or equal to 12. Yeah. So other functions itself isn't hard, like adding two functions and writing a plus sign between is not the hard part. The hard part is actually using your previous knowledge from other units to get some stuff down. Okay, we're going to do this one. You tell me, what's the domain of 2x plus 7? What is 2x plus 7? It's a line with the y-intercept of 7 and a slope of 2 over 1, correct? What's the domain of a line, of a linear function? XCR. What's the domain of a linear function? X such that XCR. So even if I asked you to add or subtract these, either way, h of x is adding. What's my domain going to be? Domain. XCR. The domain is going to be XCR because it's where they both exist. Right? So if I do h of x equals f of x plus g of x, h of x equals 2x plus 7 plus 5x minus 11. Do I actually have to find h of x, though, if I just ask you for the domain of h of x? No, if I ask for the domain of h of x, I can just look at the two functions and say, where do they both exist? Well, if one's XER and the other one's XER, where do they both exist? XER. The domain of h of x is going to be x such that x and m are the reals. If they want the equation, I'm going to add them. So I'm done. I can box it. Can I? Can I box h of x? Do I have the equation? No. What can I do? Yeah. So I can actually combine like terms, correct? I'm not done because I can combine like terms. So I'm going to go h of x equals 2x plus 5x is 7x. 7 minus 11 is minus 4. It's a line. 7x minus 4. Has a y-intercept of negative 4, up 7 over 1, up 7 over 1, up 7 over 1. Down 7, left 1, down 7, left 1, I have my line, correct? What's the range of a line? YER. I have the domain and range. Not even making you graph it, just proving a point. Okay, flip over. So what I want to tell you home here is where the domain of both of them exists is where the graph exists. So you don't actually have to find the equation of h of x if the only question is what's the domain of it. If it's the range, you have to find it. If they ask for the equation of it, you have to find it. The only way you don't have to find it is if they ask for the domain. Okay, we're going to go here. Example 2. So example 2 has h of x equals f of x minus g of x, which is the form I like. But what they could give us is they could say h of x equals f of, f minus g of x. They could write it like this. That form is real. It's just not great. So you would write it as the form that they gave us, right? Now here it says for each pair, determine h of x equals f of x minus g of x. Is it asking me for domain range or anything? No, it's just asking for equation. Let's go. So we're going to get h of x equals f of x, which is 10, minus g of x, which is the absolute value of x plus 3. Can I make that any prettier? No, I'm done. It's an absolute value of x plus 3. You can't change that. You try B and C and D. Go. Quickly. B, C, D. Remember that when you're subtracting a binomial or a trinomial, what are you going to have to do? Nope. If you have 2x minus 5, do you go minus x plus 8 just like this? You have to distribute the negative through. So make sure whatever you're subtracting, you actually subtract all the terms. So B, C, and D quickly. So this one we're going to have 2x minus 5 minus x minus 8. So you're going to get 2x minus x, which is x, minus 5 minus 8, which is negative 13. So when you combine those two functions, that's what you get. Here we're going to get h of x equals x squared plus x plus 8 minus brackets 2x squared minus 3x. So I'm going to get x squared plus x minus 8 minus 2x squared plus 3x. I'm going to collect like terms. X squared minus 2x squared is negative x squared. X plus 3x is plus 4x minus 8. And then here your h of x is going to be f of x, which is 4x minus 6 minus x minus 2 squared. What do you do when you have a square? Yep. When you have a squared, what do? You cross it off and you rewrite it twice. So we're going to have to FOIL it. So we're going to get 4x minus 6 minus x squared minus 2x is minus 4x. Minus 2 is plus 4. And then distribute my minus sign through. 4x minus 6 minus x squared plus 4x minus 4. And then collect like terms. H of x equals negative x squared. 4x plus 4x is 8x. Negative 6 minus 4 is negative 10. tonight's homework, it's not going to be on this because we're doing this in multiplication and division on Wednesday. Your homework is going to be on logs and exponent questions for your test. Because you have a test. When? Not tomorrow. That is not. Okay. So your first part of the homework is page 366. Number 5. Seven. B and 11B. And 12. That's the exponential one. Page 422. Number 6B. Nine B, 10B. D. 18A is like the question I just gave. Use a log base 10 both sides. C and D. Yeah. You guys need pressure because when you don't have pressure, you don't study. And then it goes, and then you like write the test and you're all sad because you didn't know how to do stuff. This is all different questions. Remembering that this is due on Friday, but I'm only handing out Leppy Bucks on Monday. So if I only hand out Leppy Bucks on Monday, when do I let you guys still hand in till? Monday. Why am I giving this many questions? Because I assume you have a weekend in which you're probably going to want to study for it.
So this does.
This is due Friday, but the Leppy Bucks are coming out on Monday. And when the Leppy Bucks come out on Monday, it's really just checked at 8:30 Monday morning. So when is this due? 8:30 Monday morning. I'll even put the date on. I'll change it to 8:30 Monday. I don't really care. But I need people to practice. I need people to practice before Tuesday.